Hello everybody. So today I want to talk about calculus. The topic that is about differential equations. So now I want to show you how to answer. For this one, we need to create about complementary solutions and particular solutions. So about complementary solutions, I will put about yc equals to e to the power of lambda k. Later that we need to do first derivative of yc, and we have k e to the power of lambda k in here. Oh sorry, that's about lambda. So when we do first derivative of this one, we keep the same e to the power of lambda k. Later that we need to do first derivative of lambda k. You got lambda. Now we go to second derivative of yc, and we have lambda square e to the power of lambda k. Now because this is about complementary solutions, so I will put this one equals to number 0. So I will put this one gone here, this one gone here, and this one gone here. So we have lambda square e to the power of lambda k minus number 4 lambda e to the power of lambda k plus number 4 e to the power of lambda k equals to number 0. And now e to the power of lambda k, we can do about factorization. Now we need to find the solutions of this one. This one that is about identities in here. So we have two solutions. That's about lambda equals to number 2, lambda equals to number 2. So we have yc equals to c number 1 e to the power of number 2k. So we need to change number 2 go on here. That's why we have e to the power of 2k, because two solutions that repeat about number 2 and number 2. So the next one, c number 2, s e to the power of k e to the power of 2k, and this is the answer for yc. About particular solution, we need to use about variation of parameters. So in this one, I will put about y number 1, that is about e to the power of 2k. Y number 2, that is about k e to the power of 2k. And the next one, that is about 3k equals to k plus 1 e to the power of 2k. That's it from here. So that's why we write this one in here. And now we can use about Wronskian between y number 1 and y number 2. So that should be like this. we have the matrix y number 1, y number 2. First derivative of y number 1, first derivative of y number 2. So y number 1, that is about e to the power of 2k. Y number 2, we have k e to the power of 2k. For this one, if we do first derivative of e to the power of 2k, we have number 2 e to the power of 2k. This one, we need to do the product rule of derivative. So that means we have like this. So in this situation, we need to do first derivative of k, and we have number 1. Later that we do first derivative of this one, and we have 2e to the power of 2k. Now we need to find determinant of matrix. So the formula that should be like this. So A multiplied by D minus BC. So that means this one multiplied by this one minus this one multiplied by this one. And we have the final answer. So if we simplify and we just have only e to the power of 4k. And now we can apply the formula in here. So that is about YB particular solution. We have negative y number 1, and we have the integration y number 2 gk over the Wronskian between y number 1, y number 2 dk, and we have positive y number 2, and we have the integration y number 1 gk over the Wronskian y number 1, y number 2. Now we put the formula code here. Y number 1, we have e to the power of 2k. Y number 2, that is about this one. Gk, that is about this one. Wronskian, that is about this one. And now we have like this. Now we simplified and we have like this. the integration of k squared, we have k to the power of 3 over 3. This one we have k squared over number 2. This one we have k squared over number 2. This one we have k. And now we have the final answer. So YC, that is about this one. And YB, that is about this one. Put number 2 in here. So if we simplify this one, we can get like this. This is the end. Thank you for watching.